Welcome to Everything STEAM. I'm your host, Sam Stanford. As a physicist and structural engineer with Jacobs Engineering, I've made many connections with some bright individuals who are either working, studying, or self-taught and passionate about our particular topics of discussion. This is a special edition of Everything STEAM because if you are familiar with this podcast, we don't normally conduct movie reactions. But after watching Christopher Nolan's production of Oppenheimer, it deserved an exception. So right after I saw the film, I had a bright idea to reach out to two of my former guests that I specifically knew were itching to watch Oppenheimer. And, I just wanted to see if they wanted to do a reaction episode, and luckily, they both accepted. So these guests are none other than Dr. Kevin Hickerson and actor and comedian Matthew Broussard. So if for some reason you're unfamiliar with these two gentlemen and you're new to the podcast, Kevin is a nuclear physicist specializing in probing the fundamental symmetries of nature using ultra-cooled neutrons. He possesses a bachelor's, master's, and doctorate in experimental physics from the California Institute of Technology, or Caltech, and has conducted research at Los Alamos National Laboratory, where Oppenheimer and his colleagues built Gadget, or the first nuclear bomb, and conducted the famous Trinity test. And if that wasn't cool enough, Kevin has a dozen patents in 3D printing, robotics, tablet computing, machine learning, optics, and solar energy. Now, Matt is a disgraced financial analyst forced into stand-up comedy. The byproduct of a Cajun chemist and a Jewish microbiologist, he holds a degree in computational mathematics that he always manages to bring up, and just did, and is fully aware how douchey he looks. His comedy is heady, self-effacing, and weirdly educational. He's performed on The Tonight Show, Conan, Jeff Ross Presents Roast Battle, the Comedy Central Half Hour, and some stuff with MTV2 that he doesn't really want to talk about. You can catch him in The Marvelous Mrs. Maisel, The League, The Mindy Project, and alongside Billy Crystal and Tiffany Haddish in the film Here Today. And last but certainly not least, he is the creator of the webcomic and puzzle app mondaypunday. And after the episode, if you want to hear more of Kevin and Matthew on this podcast, I recommend that you check out my episode called Asymmetries of the Universe and Big Numbers, where Kevin and Matt starred in those respectively. So, now that you've been introduced to my guests and the topic of this podcast, we're going to head into this special edition where we plan to talk about Christopher Nolan's film, Oppenheimer. Enjoy. Kevin, Matt, welcome back to the podcast. It's been a while, I guess, between, Matt was here, like a year ago you and I recorded, and then Kevin was just a few episodes ago. But hey guys, welcome back to the podcast.
Well, thank you. Thank you so much.
Thanks for having me, man.
Yeah, this is a very informal but special edition of the podcast where we're going to be talking about Oppenheimer, the movie Oppenheimer, and then also some fun sciencey aspects towards the end, whatever talking points that we really want to talk about. But I want to start out the podcast just kind of getting an overall take from all three of us, and then like I said, we can jump into some talking points. So, Matt, please take us away, man. What'd you think of the movie?
Spoilers ahead. I would recommend turning this off now if you haven't watched it, because I am not holding back. I really liked it. I like Nolan. I liked Tenet. I really enjoy. The only thing I think you missed on was that third Batman movie, but I really like everything the guy does for the most part. It was really good. The acting was phenomenal. I thought it was shot in a really pretty way. I did not mind the non-linear storytelling. A lot of people found that annoying. I found it pretty interesting. Yeah, because you could basically, it created kind of the emotion of it being the through line rather than the events of it being the through line, and contrasting how he felt afterwards and before. I thought it was really cool that you never really saw how much it bothered him or why it bothered him. Like you couldn't, there was speculation into whether was he faking, like he felt bad about it or had conflict about it just for political moves, and we'll never know. And that's also a good lesson in life. We'll never know what really goes on inside people's heads. I love the exaltation of science, but also the showing that scientists are very flawed people at times, and the monotonic pursuit of science can lead to bad and good things. Yeah, I also like they didn't make the scientists too charismatic. I really hated that one movie with, I think, Dev Patel, where he played Ramanujan, but he played it as a sexy heartthrob. I'm like, nope, incorrect.
That's funny. I liked that it was the other way around, Matt.
What? That he was sexy? Yeah.
I thought they showed him as a player and everything. It was that felt more realistic, compared to Big Bang Theory, where they just make scientists all look like we're mega nerds and stuff.
It split the difference. I thought
Yeah,
it did
there
a
you
good
go.
job of
There you
like
go.
it wasn't that I'm such a bumbling like he's a charming guy. And there were quotes in that movie where I was like, there's no way he's that good with words. And then I looked up the quotes. I'm like, oh, he actually spoke very well. Yeah, and I like the third act. I like where it was kind of this big misdirect that the bomb working and Hiroshima and Nagasaki were simply the end of the second act. And the third act, the drama actually rested in an FBI clearance meeting and a Senate confirmation hearing. And they made that as exciting as anything else in the movie. So overall, I really enjoyed it.
I really loved it too, man. I love this movie so much. I loved it before it came out, but
Yeah.
I also heard people complain about the nonlinear part, and I gotta say a funny thing that made it not at all a problem for me, and so this might have been part of the why it was a little unfair, is I knew who all those people were, and when those events were, and everything about it already, because that's already just part of my life experience. So it didn't feel jarring to me because I knew exactly when those things were happening. So
yeah, if you're a fan of physics or science in general, though, all of those scientists are I would say the Chicago Bulls in the 90s,
yeah.
where I'm no expert, but just the number of names popped up. I'm like, oh, cool. Like, was Dirac in it?
No.
Enrico
Okay.
Fermi was.
Fermi, yeah.
Fermi,
yeah.
You recognize names, even if you're just casually, like, my background in science, I just read Wikipedia articles from time to time, and it was still really neat.
Oppenheimer did work with Dirac, but he wasn't in the movie. Or if he was never a major character. But.
Fun Dirac fact about Oppenheimer was, I don't know if you saw the letter of recommendation Oppenheimer wrote about Feynman.
Yep.
Can you quote it better than me?
Yeah, I can't quote it exactly from heart, but yeah, he said like he's a lot like Dirac, but a lot easier to be around. Or something
Yeah.
like that, so.
Yeah, I was looking at like some other quotes from other famous physicists. Like Wolfgang Pauli actually created like a funny quote, but also like a dig towards Oppenheimer. It was like he's a genius, but like he never gets his calculations right or something like that.
Okay.
But
Yeah.
like
Sometimes you forget to carry the Y, so.
It happens. I mean, like other physicists kind of commented like, well, he's an absolute genius. He knows what he's talking about. He has a background in chemistry. He understands metallurgy. Obviously, did work in theoretical physics, but he just didn't like to sit down and write long form calculations. And that was really it. But he was like an upfront and absolute genius from what other physicists have said.
Einstein didn't really like to do that either.
Yeah.
A lot of people don't realize that, but Einstein, like, a really good example is he never solved. He made like one numerical solution that he approximated to his own equations, and he basically never solved his own equations. He created this like great theory. It took a guy fighting in the middle of a war in World War I to be the first person to actually bother to solve even the simplest case of his own prediction.
Was that for general relativity?
Yeah.
Mm-hmm.
Yeah.
Yeah.
That was the scene in the movie, and I don't have the historical context on it, where Einstein and Oppenheimer were talking about being bad mathematicians. And I found that kind of annoying because people are going to watch that and be like, me too. I'm like, when they say they're bad at math, they're still better than anyone you've ever met has ever met.
Right.
Yeah.
Well, to some degree, though, I mean, one nice thing that appealed to me about Einstein is he was really bad in grade school. And I had the exact same problem. I'm not bad at math. Matthew, we talk about math a lot. I'm pretty good at math, but in grade school I was not. And my first grade teacher thought I was a complete failure at math. And Einstein had a really similar problem in childhood. Like he couldn't do arithmetic. He couldn't do basic things like that. He couldn't spell things like so. Yeah, I understand what you're saying, that you don't get to just like, hey, we're all bad about good. We're the next size up. But still, the point is, you shouldn't think that you're not possibly, if you feel like you have other talents, you shouldn't think that something like that is holding you back early. You shouldn't give up just because of that, because sometimes there's just parts of it that aren't particularly relevant down the road to the harder stuff. So
right.
Yeah. And it's
then again, so many of the best mathematicians were actually just physicists who had a little bump in the road and had to create a new branch of mathematics just to arrive at their destination. I think Einstein falls in that category. Newton falls in that category. I believe Feynman. I know he's attributed with Feynman integrals, though I don't know they're actually his creation. He just
he did that. Yeah, and he came up with perturbation theory for quantum electrodynamics and quantum field theory.
Mhm.
And what's really hilarious is that I know a mathematician who, even though this is considered a great achievement, and he helped make the most accurate physics theory in history. About 40 decimal places of accuracy is his theory. No other theory even compares. And yet, I remember there's this mathematician at Caltech who I won't name, but who was just adamant how frustrated he was that this perturbation theory wasn't accurately defined and it wasn't numerically.
One thing that I really enjoyed about the movie, and sorry, not to jump back towards like movie details, but I really enjoyed the fact that there was no CGI to this, and it's kind of funny, like with all the technology that we have, it's like, oh, it's really refreshing to not have CGI. But like we're talking about like maybe like a decade ago or 2 decades ago, it was like a huge flex to say, oh, we got this many shots of CGI, and it was, I don't know, I thought it was really refreshing.
It's pretty. It's a pretty movie. I like everything about it. He probably spent too much money. He probably could have cut corners, and I would not. I would say 99.9% of us wouldn't have noticed. But
yeah.
Hey, it's a real cinephile's wet dream. It reminds me of a lot of the more talented scientists in my life. My father kind of, he's not on that level, but it's just a lot of people who are really good at science and really good at math.
Thanks,
their
man.
talents get wasted in management.
I just dropped in to take credit for that.
Yeah. But the whole thing of him is just being a brilliant scientist who has to become a manager of people, and that's never as fun as just being the pure science side of it. And I have a question for Kevin: is you understand what these people discovered? I don't. Where does Oppenheimer rank among the greats in terms of his non-Manhattan Project discoveries and contributions?
Pretty good. Not super high, but definitely not low. I think one problem is he got a lot of points knocked off of him just for working on this.
Mm-hmm.
That kind of like there was sort of I don't mean that he was blacklisted by scientists or something, but definitely people were not eager to credit him with anything, And then there were some other circumstantial things which was mentioned in the movie, which I really like the fact that he predicted black holes would have been a much bigger deal had it not been published on the day that Poland was invaded, like that was, and that his life immediately changed. It wasn't just that it happened on that day, but also like he had no opportunity to then go and pursue this or publish it. It was like he immediately that was moved to the side.
Wait, he predicted black holes?
Yeah.
Mm-hmm.
Yeah, that's in the movie. They
yeah.
He was the first?
Well, he didn't. Okay, there's some subtleties because there's different people who predicted different parts of black holes. Several scientists. So the first person to predict a black hole at all, being I kind of mentioned him earlier. The guy who solved Einstein's field equations first was Schwarzschild, who was fighting in.
Is the radius named after him?
Yes.
Yeah.
Yes.
Yeah.
That was one of the solutions to the Einstein field equations. If you remember back in the movie, one of the students, I think his last name was Alvarez or something. I could be wrong by that, but he ran in with the newspaper saying like, hey, they've created the first fission in the lab. And that was when Oppenheimer was like, no way. And he started doing calculations on his blackboard. Like right before that scene, he was working on black holes.
So yeah, just to get back to Schwarzschild predicted the mathematics of a black hole, but that being the solution, that's just saying this is it existing. Oppenheimer showed that a star would have the ability to collapse and turn into one. And there's other components too that were along the road. Like one of the other components was that people weren't sure if neutron star formation would stop the creation of a black hole. So there's little pieces all along the way.
Yeah. I remember the movie with what's his name, Hawking. They had that movie about him, and they credit him with just like inventing even the notion of a black hole. I'm like, I don't think that's correct.
That's not correct.
Off by 3 decades.
yeah.
It's off by a bit. He was not alive at the time black holes were predicted. So.
No, yeah.
But Oppenheimer, I think, was in the running for the Nobel Prize 3 times. Yeah. And one of his students actually won a Nobel Prize. And he was 3 years younger than Heisenberg, and he followed up and expanded on a lot of his papers in quantum field theory. I'm pretty sure, and maybe not just quantum field theory, but just like in quantum mechanics.
It's funny that Hawking was credited with coming up with black holes, because the thing that Hawking is most famous for is that he proved in theory that black holes aren't permanent. So he almost uninvented black holes.
Right, they
I think it's
evaporate,
hilarious.
right?
Yeah, that they evaporate. So I think it's funny that people gave him credit. He's like, no, he literally undid it, dude.
So
he fixed
bad.
it.
That's why this movie is so good to me, because it doesn't try to like simplify things. Just yeah.
I really liked all the they put in a lot of technical terms without it being saying they're trying to explain the odds, which would be really boring and weird. They put in a lot of terms in there that I really liked, that it was really well crafted in terms of the science consulting and stuff like that. Although it probably makes sense because Kip Thorne did help with this movie also. So that was my relativity professor. So yeah, props
legend. The one scene I appreciated was they were talking about how to, once they've enriched the U-235, how to actually make it explode, how to bombard it, or potentially the plutonium. And then they even brought up hydrogen, which was the or deuterium, I think, all as 3 methods of fission. Are they all fission?
Deuterium is for a hydrogen bomb. Yeah.
Okay? So that part I didn't understand much in the movie. Could you explain the difference with the hydrogen bomb?
That's fusion.
Yeah,
fusion.
Yeah. So in the movie, they're making. I mean, they discuss both
sense.
types. They're discussing both types of bombs. They're discussing the fission bombs, which came first, and then the fusion bombs that came later after the war. And that's the one that Teller was a big champion of. That one is pretty cool to see Teller in there, because if you read my thesis, which I don't recommend you do, but if you want to, it's online. But one of the things I measured was related to something that was predicted by Teller, and so it's named after him. I measured something called the Gamow-Teller component of the Fierce interference term of the neutron. Well, it's a mouthful, but it's cool that it's mentioned in the movie. I like that. I was like, hey, I know this. So I know those people.
Oh, sorry. Did they have actually was fusion bombs like on a reasonable timeline, or would they not have completed that?
Well, as they showed in the movie, Teller was trying to jump to that first, and he was always doing that, and he was saying, look, this is going to make it work a lot more efficiently. And Oppenheimer addressed that, and he's like, okay, I get this. And this is a mistake actually a lot of theorists and physicists make a lot of times. Sometimes they think the correct answer is the best answer, or the most correct answer, or the most efficient. And in reality, one of the things engineers and actual entrepreneurs are really good at distinguishing is sometimes the enemy of perfection is good enough. Sometimes you get something, if you get something done fast, that's 100 times more valuable than just the best solution. And a lot of times if you spend too much time in the lab or you're even on paper, then you get stuck in this like, well, this is the best solution, so it has to be like this, but that could be 100 times harder. Anyway, it wasn't 100 times harder, but it did take 10 more years to actually make a hydrogen bomb. So Oppenheimer was correct that if you're trying to do it to win a war, making the hydrogen bomb would not have been very useful. In particular, hydrogen bomb is a little misleading. Sometimes they think that it's like it gets hot enough and then it's all powered by fusion. Afterwards, and the components of fusion, it's called hydrogen, but it's actually isotopes of hydrogen. It's deuterium and tritium, although they don't actually put tritium in the bomb. They put lithium-6 and deuterium. Lithium deuteride is the material, but the tritium is made very quickly. But what these two things actually do is it actually greatly amplifies the fission process in addition to setting off the fusion. So it's not nearly as simple as just one starts the other. It's actually the two work together pretty well, where you get a much higher efficiency use of the fission core by having this fusion process next to it, and that's why even extra energy is even coming from the fission itself. So you mentioned the little boy bomb was not very efficient at all. It wasted most of the uranium that went into it. They simply couldn't keep it trapped fast enough that it all burned up. I mean, because the second it starts to heat up, it's expanding, and it very, very quickly moves away from critical mass. But if you have a fusion source with it, it can irradiate so quickly that all of it gets used up. So
it shoots neutrons back into the system.
Yes.
Okay. I don't know if you've ever gotten to see it. There's a wonderful mini-series called The Heavy Water War that was put on by, I believe, like Swedish public television, but in conjunction with a number of nations public television. It's about, do you know The Heavy Water War?
I don't know the show, but I know about the war.
the history. Oh, it was.
I know that they're racing to try and get heavy water. Yeah.
Yeah. So they basically, there was efforts by our team to sneak in and destroy their source of heavy water, the Germans, because it would have aided their research, and they went on skis at night under a full moon, and there was all sorts of subversion and subterfuge.
Yeah, I mean, that's also a really great example of why it would have made no sense to go after fusion first, and because they were doing it wrong. The Germans were doing it wrong, and they also, because they were trying to collect tritium and put tritium, and they were trying to mix deuterium and tritium, and tritium is very hard to find. Although not if you're off the coast of Japan this month, but no, it's still hard to find. But they are releasing tritium into the thing, although a very small amount.
Yeah,
compared to a lot of water. But so I'm not trying to scare anybody, but
we don't want anybody woo out here,
but, But it is related, because a lot of people say, well, why don't they just take the tritium out? Well, it's very hard to take tritium out of water. It's very diffuse. There's not very much of it. It does not last for a long time the way uranium does. It's not from the creation of the Earth. It's from the last 12 years. It's from the upper atmosphere, actually. It's created by cosmic rays hitting the atmosphere. So it's not, there's a very small amount of it. It's from a few other nuclear processes, but it's a rare material for the reason that it's not just around. It doesn't sit there in the ground like an ore. So the Germans were trying to sort of collect it, and that was a dead end for them.
Yeah. So
they
Kevin,
they got rid of all their Jews, which how are you supposed to get new? That was my favorite line from the movie, where they were like, "Well, they got rid of their Jews, so we have that going for us." As a Jew, it made me very proud.
That's happened a lot throughout history, is like when you have a government that randomly picks something they don't like about a group of people, they greatly cut into their own their own brain pool or their power pool. And I think that's one of the reasons why America won, is that I think we've been pretty good. I mean, we've had some flirtations with that policy kind of thing, but I think we've generally been pretty good about not trying to count out whole sections of the population to listen to. So I think that's part of why we developed it first.
So you talked about Little Boy and how it was extremely inefficient. I think they put like 64 kilograms of U-235, and I think only maybe at most a kilogram like went off. So it was extremely inefficient.
By go off, that means only 1 kilogram of U-235 converted to U-238, or would it have converted, or would it
split? It fizzes. It's called fission because it's split.
Sorry.
So it converts into things like fission products like xenon and krypton and things like that. There's actually a whole distribution. That's the fallout. Actually, that's one of the things that causes fallout, is that it splits into two, and those two pieces left over are still radioactive for many years. That's the part that actually causes the sort of after effects of fallout, and in both nuclear power accidents and also when a bomb goes off. So only a small percentage of it burned, and so the rest of it just stayed as U-235 and just sort of sat on the ground, didn't do anything. And that stuff's relatively harmless, actually. U-235 is not harmful as fallout. So, but it does not make the yield very high. It causes the yield to be really constrained.
What's the half-life of U-235?
Like billions of years. Or something like that.
But it's still there.
I don't even memorize. Sorry.
So
it's like math in first grade.
So that's what we dropped on Hiroshima, but that wasn't what we were testing for the Trinity test. That's a different type of bomb. That's like an implosion bomb. It
was a plutonium implosion bomb. So the reason that they used the Little Boy one is because even though they knew it would not be efficient, they also knew the chances that it wouldn't work were incredibly low, near zero, as they mentioned in the movie. The chances of it not working were near zero. It wasn't 100%, but they knew that they could still slam this thing into the other thing. That would be enough to detonate something, but they knew it wouldn't use it very well. The implosion was much more of an attempt to really get more of the output from that. And even that's not very efficient. And a really good demonstration of this is, I mentioned modern day fusion bombs, or even tactical bombs that are only fission only. And while that bomb you saw it in the movie, was huge, like this big, a modern warhead is roughly it's a cone roughly this big, and the plutonium core is like the size of an apple or smaller. It's nowhere near as big as what they had, and the big reason for that is because after as more weapons were developed over the time, they got much better at greatly increasing the efficiency.
That's great, because those old ones are taking up a lot of room in my basement. I'm so sick. When I have to move, I have to hire people. It's heavy.
Right. I mean, the main reason for better or worse, the reason this was important is because as demonstrated in the movie really well, beautifully, actually, the way they showed that, once these things were put onto ICBMs, you don't want a giant thing the size of a Volkswagen Beetle to be launched into space, because the odds that that's going to get there fast and it won't, it will take a Saturn V size rocket to launch becomes pretty impractical. Whereas
also a lot of fuel, and that contributes to global warming.
Yeah, you don't want to warm the planet right before.
You don't want to warm the planet when you're sending missiles to destroy whole cities. You definitely want to think about your carbon footprint.
Right. Yeah, absolutely.
That's a heavy payload.
Right. So modern ICBMs on almost pretty much all countries that have them. There's multiple of these things, usually called MIRVs, multiple reentry vehicles, and these MIRVs have very tiny components, and yet they have enormous yields. They can have yields up to 10 megatons. So really big.
That's
sleep tight.
That's insane. So the implosion bomb that they made for the Trinity test and then for Nagasaki, that was multi-layered, but it's spherical, and on the outside, right, is like the layer of explosion that creates a compression, and then beyond that, there's a layer of, they want to contain the neutrons. It's like a neutron containment layer, right?
What is it?
Beryllium. There's other neutron reflectors, but beryllium, and that's, believe it or not, the exact same type of reflector we use to trap neutrons in, like, the most recent experiment I worked on, which measured the neutron lifetime. Well, not the neutron, sorry, to measure the neutron decay symmetry. We have little mirrors with a very thin coating of beryllium. Now, you can't use that in a nuclear bomb because when they're traveling fast, they need a lot of beryllium. They have to have a large, thick section of beryllium, but the kind we use are very cold. They're ultra cold, actually. So they bounce off of just the slightest amount of beryllium. But beryllium just happens to have something called a high neutron scattering cross section, which means that when a neutron runs into it, the chance that it will bounce off of it is very high. So it's sort of like, silver is to light, like neutrons are to the stuff.
Does it momentarily become an isotope or something and shoot it back?
It's called an elastic scattering cross section. So it's elastic because it bounces off of it and it does not absorb. If it absorbed, it'd be called an inelastic cross section.
Mm-hmm.
Got it.
Yeah.
So that's the shielding layer you were saying. Sam?
Yeah, and then there's like the layer of plutonium or the uranium, and then in the
you skipped a layer. There's a pusher. That one's important too. There's a thing called a pusher. It was made of aluminum, and it was basically like a big piston to make sure that thing really squeezed.
Was actually, yeah, that's true. And then in the middle portion was called the urchin. The urchin that also, whenever things were compressed, it would then also shoot out more neutrons to increase the efficiency of the chain reaction.
Yeah, that thing, and there's a great scene where they're putting that thing in. They show them lowering a thing in a special container. They did have to be really careful with that thing because it's actually, while it couldn't detonate, that thing could actually harm them if it broke or something like that, because it could give off a lot of neutrons, which was its purpose. That thing's called a neutron initiator. And it's a pretty clever design too. What's great, what I loved about this movie is, well, I knew about this thing working. If you looked up at Wikipedia or something like 10 years ago, or tried to find this in the internet, this wasn't just stuff you'd find. And I strongly encourage you to consider the fact that that's almost still certainly true of all the other components. So don't take anything I'm saying as a word, but the current declassified situations, that thing's called a neutron initiator, and it had a polonium-210 source in it. Polonium is an alpha emitter. It had another metal that what those alphas would hit. It was it would hit that metal, and then it would release a whole bunch of neutrons. And the idea was, once they designed this thing so that once it collapsed, they would immediately mix, and it would just give off this huge burst of neutrons all at once. Yeah, and that was the thing to sort of to start the chain reaction even faster than the chain reaction could start itself.
Yeah,
clever.
Yeah, it had a lot of parts. I can assure you, the modern ones have even more parts. And I said, I wouldn't say like, oh, I looked it up on Wikipedia, I can design one now. That's not a really. You're seeing what you've been allowed to see so far.
Yeah.
The CIA is giving you side eye whenever you say that. They're like, That's cool. So
I go out of my way to never give anybody ideas that I haven't already seen published by somebody else. So I'll just tell you that.
That's fair. That's fair. So we talked about the bombs. So what about the other? Because obviously the main portion of the show or of the movie was about Los Alamos because we're talking about Oppenheimer. It's kind of through his lens, right?
Mhm.
What about the supporting cast in terms of laboratories that were across the United States? The two that come to my mind is Oak Ridge, and then I guess it's called the Met Lab, but it was at the University of Chicago. Do you have any comments on that?
Well,
And
they
that
were
project?
important because they weren't necessarily designing or doing the other stuff, but those places were really important for manufacturing the isotopes and things that were going to be actually used. And this process started off just like the bomb started off very efficient. This process started off very, very inefficient.
Yeah.
For example, enriching uranium-235 from natural uranium, mostly separated from U-238. They used giant magnets and to do this because that's how chemists knew how to do it. They were like, oh, you make a mass spectrometer. That's how you separate things of different mass. That's a really, really inefficient way to do it. In fact, this was so inefficient. These magnets were several stories tall. They ran out of copper. They couldn't use copper wire, so they had to dip into the silver stockpile of the United States. There was like a significant fraction of the United States' silver in these mines. I mean, in these magnets. And this took a huge amount of electricity. It was really the worst way to do this. It's just that it was on paper. It was at first it was like, okay, that way will work. We know it will work because I built a little one and it works. Let's scale that up.
Is this to separate isotopes? Is this what they're using?
To separate U-35 and U-238.
Now they use centrifuges, right?
Yeah, although even more important is they don't really worry about it very much anymore. I mean, they do it for making fuel for power plants, but almost no new warheads really use uranium anymore. Uranium itself is not even a very efficient thing to use, and it doesn't have as good a yield. And so pretty much all warheads use plutonium now.
Yeah.
And I think we were going to talk about how plutonium's made. It's made in a much easier way that is you couldn't do from the beginning. That's part of why they couldn't do this technique. That's why the two were racing in the beginning. They knew about how to do it, but there's a very specific reason why they couldn't just make a lot of plutonium in the beginning. Now it's easy to make plutonium. Very, very easy.
Can I ask a question? So does plutonium work the same way in that there's a less stable isotope that decays faster and you have to
No, it's made in a totally different way. So there's no natural plutonium. So uranium is the last natural heavy element.
That's
and
stable.
It's the last natural one because from the creation of the solar system, like 4 or 5 billion years ago, that there was some sort of kilonova, a collision of neutron stars, and a huge amount of isotopes, heavy isotopes, gold, lead, uranium, all these things were made in this kilonova. Interestingly enough, Kip Thorne helped us record the first kilonova ever because LIGO, his gravitational wave detector that he helped make, could tell that there was a kilonova and could tell where in the sky it was, and told all the world's telescopes to aim at that kilonova and watch it. And so every single telescope spectrum that we have on Earth, including the Hubble telescope and all that, all aimed at this kilonova.
Do I still have time to rush over there and gather all the gold and other valuable heavy elements? No. Damn.
It made a lot of gold though. It supposedly made something like I think I saw like 3 Earths worth of gold or something like that.
Dang.
Like just in a few seconds.
Sell.
Yeah.
The price is going down.
But anyway,
the market's flooding.
In that collision, in the kilonova that happened right before Earth was made, absolutely a lot of plutonium and way heavier stuff was made. All of the heavy stuff was made. The difference though is that uranium is the only one that has long enough that as lifetimes on the orders of billions of years. So that stuff's been slowly decaying away, but we're still here to see it. There's no long-lived plutonium one. The longest is like 10 million years or something like that. I don't remember.
It sounds like to create plutonium, we're going to have to use fusion. Is that right?
No. So the way you make it is that if you take uranium-238, which is normally useless for this sort of thing, it's not fissile, it's not doesn't have any other nice properties. And once you have a nuclear reaction going on, neutrons are flying everywhere. And if a neutron hits U-238, it fairly quickly turns into plutonium-239. And so that's how you make it.
Right.
And that's called the breeder reaction. So if you've ever heard of a breeder reactor, that's the reaction that happens. And this happens inside of all nuclear reactors. This is how North Korea got its plutonium. They tricked outside inspectors by who were there to watch their reactor running, and they kicked them out for several months. This happened in the 90s. And then when they came back, they said, oh, it's fine, don't worry about it. But what they had actually done is they had removed all the cores, and they had processed all the plutonium out, and they had reinstalled it. And the inspectors were not able to tell that they had done that until it was too late. So this is how you can get plutonium. Does
a neutron become a proton?
I mean, yes, it can turn into one. It can decay on its own. It definitely does.
Wait, is plutonium have a higher element number than your? Yeah. By how much?
By 1.
By 1. Oh, okay.
Yeah.
Oh no, by 2. Wait,
it goes into Neptunium.
Neptunium. Yes.
Yeah.
They're in the order of the planets.
Yeah.
Although, you know what? I think it's weird that plutonium never got kicked off the periodic table.
Ooh.
Yeah.
It's so weird to me. Somebody should just be like, plutonium's not an element.
It's not an element.
Where's Neil deGrasse Tyson when we need him to discredit Pluto?
That process creates plutonium, and now you have some plutonium. How long is that plutonium going to stick around, and how dangerous is it to stand near?
It sticks around for a long time. I don't remember its half-life. Sorry, I should have this memorized, but I don't.
It's not long enough. Microseconds.
Yeah. No, it sits around, and it sits in the warhead for a long time.
And there's no need to enrich it. It is.
Nope. It's okay. So I mean, there's processing and stuff, but no.
Now, which is the slower process? I guess at that time, was the slower process.
The reason, so that's why I said at the time the movie showed it, the two looked in competition. Now there's really no competition. It is way cheaper and faster to make plutonium than it is to enrich uranium. Not that it's hard to enrich uranium, but we kind of enriched it all already. We actually have too much enriched uranium, so
it is harder to make uranium when you have Stuxnet embedded into your nuclear enrichment facility, I've heard.
Yes, it is. That's right. It is.
It's a real pain in the butt.
Breaking, yep.
American Israeli spy intelligence services put the secret code into USB drives and shut down your uranium enrichment facility. Always annoying when that happens.
Yeah, but suddenly your enrichment things think they're playing Pokemon Go or something.
That's awesome. So I think one other thing that would be really fun to talk about
sorry.
Yeah, go for it.
One question. And how does hydrogen compare to all that now? If you're looking for, let's say you're making a bomb, what would be the best way to go? Plutonium still, or is hydrogen fusion bomb even better?
That's a good question, because they discussed that a lot in the movie also. I mean, they point this out. This is one of the reasons Oppenheimer was not super thrilled about hydrogen bombs, is although that they were really big, and this was really clearly made with the biggest of them, the Tsar bomb, which was roughly a 50 megaton bomb. I mean, the Tsar bomb blew up things, even though it was on a fairly remote island in Russia. It caused destruction to buildings in towns that were nowhere near the test site. And so there really was a point where a hydrogen bomb doesn't really give you much usefulness except for panic. Except for deterrence of that your country will not exist, because it goes way beyond blowing up a missile base or a military base or city even.
It sounds like bringing a grenade launcher to a shooting range.
Yes. Yeah, exactly. Yeah. So this is why they're separated into two categories, strategic and tactical. And those are really good names, because they have a strategic use, which is don't mess with us, or this will be this is what's going to be left. But they have very little
terror and murder, I think, are the two words they mean to say.
Yes, that's the words I was thinking. Try to avoid saying those. But tactical use, like, this is still for fighting an army, like that's really what that is. We live in a weird world now where this is not publicized a lot. I mean, it's not secret either, but our warheads actually you cannot tell necessarily what mode they're in at launch time. And then even weirder, we have weapons that can be given instructions to switch modes even after launch.
Wow, and what a fun surprise.
Yes. Whoa. So you don't know if a warhead, some of our warheads are coming in, you don't know if they will not detonate at all, or if they will have 1 kiloton yield, or if they could have up to 10 megaton yield. You don't necessarily know.
It sounds like they're non-binary.
and hopefully there's no bad malware installed on them, because it's probably not going to go well.
Jesus Christ, that's an alarming thing to hear.
Hopefully it knows it's a nuke and not playing Pokemon Go. So. It's like, I see one. Oh, oops.
I've heard. Sorry, one other thing about like the details, because I like hearing you explain this, Kevin. I'm really good at reading like half of a thing and then just not reading and then just like thinking I know something. I read something about nuclear bombs now having a more strategic, maybe I already spoke about this, but a much more contained radius. So when they talk about firing nukes at people, it's not necessarily that there'll be such a massive fallout. It'll hit its target and do a much more localized damage without causing like decades of uninhabitability.
That's the primary purpose, allegedly, of nuclear weapons at the moment, is that if they do need to be, and this is fairly universal to both America and Russia, that if anyone were to use a nuclear warhead in war in the future, they would use it much more for the purpose of taking out an immediate threat or immediate danger. Like I said, like
New York City.
Like New York.
People are rude there. I went there one time. People are real jerks.
You just say that because you live there.
Nice.
That's if the U.S. launches on New York itself, which might happen. Yeah. I mean, it's not off. It's near zero, but it's not zero.
That was a great. That was such a funny scene. Matt Damon did such a good job with the scene because it showed the mistranslation between the people who talk in numbers and people who talk in military speak. If near zero means what it means, but
yeah, and I think he was talking about like an atmospheric incident where you just have a continuated chain reaction, and that's something that Compton brought up to Oppenheimer.
Teller also did this, and part of the reason because he understood how hydrogen bombs work. So in a fusion reaction, what you have in a fusion reaction is a process called, first of all, they're not called nuclear weapons, they're called thermonuclear weapons for a reason, because while a fission reaction can occur at zero temperature or very low temperature, meaning the neutrons have to have no energy, they can just be flying around at room temperature, and they will still create the chain reaction, and they'll very quickly get hot. In fact, the chain reaction actually stops it. That's one of the things that slows down the efficiency. A thermonuclear reaction is very different, where it only happens above a certain temperature. And when I say a certain temperature, I mean like millions of degrees, millions to hundreds of millions of degrees. And that's why this only happens inside the sun, because the sun is very hot and very dense. It has to be even hotter inside of a warhead.
So I think I can actually build upon that just a touch, because no, you're good. So the Trinity test, they did a calculation. I think it was Compton, Fermi, and then
that was the original point. I was sorry to re-interrupt, but
no, you're good.
The ignition of the atmosphere. Yeah. So the reason Teller was interested is he was calculating what would you have to do it in a warhead, but at the same time he was going like, well, never mind a warhead. What would you have to do if it was just around the warhead? What is the thermonuclear ignition temperature of the air itself, meaning the oxygen and nitrogen and carbon and hydrogen that are in the air? Because there is stuff, and you can't ignite it.
Let me chime in here. Yeah. Oppenheimer was not the first movie where I heard of this concept of atmospheric ignition.
Really?
I heard it in the original Fantastic Four movie, where Mr. Fantastic warns Human Torch that if it gets too hot, he could ignite the atmosphere. And I thought that was absolute bullshit when I saw it in college on a Redbox DVD rental. And then I saw it again in this movie, and I was like, "Oh, that wasn't bullshit." Someone actually kind of knew a bit about science when they wrote that scene into the movie.
It was also Christopher Nolan left an Easter egg. It is mentioned in the movie Tenet. There's a scene about Oppenheimer's reference, and one character is talking to another and says, Oppenheimer was worried that it showed that Christopher Nolan was already really excited about this idea, which he spoke about all the time. He said that's why he made this movie, was because of that weird idea that they had to sit there calculating, like, well, if we do this, we win the war, but if we do this, we all die, and he just found that so fascinating.
What is the maximum temperature during a thermonuclear detonation? Explosion?
That's where I was getting at, and so if you actually use the Trinity test, it would have had to have been 10,000 times the temperature of the core of the sun.
It's much hotter. The sun is not particularly is not as hot, and it's not like a constant thermonuclear bomb.
You hear that, son? You ain't shit.
Yeah, that's right.
Shots fired.
There's a lot of reasons
for the magnetosphere feeling safe.
There's a lot of reasons for that. One is the sun can't go, the heat can't go anywhere. It's trapped. The sun is always pushing. It's basically like a nonstop implosion bomb because gravity is the implosion force all the time. So all it can do is push the sun out, which is why the sun is so big. I mean, well, it has a lot of mass, but I mean, it's also expanded to that size because of the heat, but it's constantly trying to push back in. So it doesn't need to be as hot for the process to happen. Also, this process is happening continuously over billions of years. It doesn't happen in a microsecond. And so it doesn't have this blowing itself apart problem. And that's always the thing that cuts into the efficiency of a bomb, is that if it blows up faster than it can burn its fuel, then you waste all the fuel that you put into it.
Yeah.
So
that's great. Yeah. Hotter than the sun by a lot.
Yeah. It's about 100 million degrees. Is like, yes. At least as far as I know. Like again,
for a millisecond of the outer sphere, right? Like really, it's only like over a very small area for a very small amount of time that hot.
Yep.
Yeah. It was like I think they averaged it out to be like 20 times the current total of all of the warheads that we have combined. Like all of the thermonuclear warheads would create that sort of a reaction in the atmosphere. But yeah.
All of them,
like 20 times the total amount that we have on Earth going off at one time. But
even that, I'm not positive about this, but even that, it's not the correct temperature either. You know,
we need to do a MythBusters episode.
There it is.
Yeah. I don't know the exact temperature, but I'm guessing it's hundreds of billions degrees, or trillions of degrees is really the issue.
But if that happened at one point, that reaction could ignite the rest of the
atmosphere. It would be a chain reaction. Yeah. I mean, it would ignite.
A little in the weeds here. What is that? What is the atmospheric ignition? What chemical process is that? Is that the nitrogen?
No, it's a nuclear process.
Yeah.
It's nuclear. It's a thermonuclear process. And this process does happen in stars, but just to give you an idea of why it's so near zero, this won't even happen in our sun. Okay, our sun is not capable of igniting oxygen and nitrogen. Those can ignite, but those ignite inside of a star that's bigger than our sun, and that's called the CNO cycle. And it's very important because it's a big part of why we're here, why we exist. We were made in this process, the ignition of nitrogen, oxygen, and carbon. It's called the CNO cycle because it goes in a cycle and it just creates more and more nitrogen, oxygen.
Yeah, question. Ignition of nitrogen, carbon, and oxygen. Is that just the nucleus breaking apart? That's the nucleus breaking apart into
it's a little more complicated
components?
They bind together and they produce things. It's a cycle because they spit some things out and then those things combine to make things. So one of the things they spit out is an alpha. And if they spit out 3 alphas, if you take 3 alphas and you combine them, you get a carbon-12 atom. And so that continues the process. And this happens inside of larger stars. Our sun is not big enough. It will produce very little carbon, nitrogen, oxygen, even by the time it's dead.
So a very violent process.
Well, it's not violent. It's that the sun has to be even bigger. It has to crush it even more. There's not enough density inside the sun to really keep this process going.
Yeah, so I think you can actually read the declassified calculation that these guys made during the Manhattan Project. And what they did was they quantified a factor of safety. And if you're only looking at the fusion gains, which would be the denominator, and then and Kevin can expand on this a little bit more, but I think it's called the breaking radiation. You get like a factor of safety of 1.6. But then whenever you incorporate temperature and then like the inverse Compton scattering, it's like a stupid, crazy high factor of safety. So
near zero.
It's near zero. But it's cool. You can actually look up the calculation if you ever wanted to do that. Yeah.
We're probably safe. It's probably fine.
It's
probably.
We're good. Yeah. I mean, we're still here, and they were setting off hydrogen bombs after the Manhattan Project. So,
do you watch Kurzgesagt?
I do. Yeah.
They did a good one. Sorry to reference other content on here, but they did. What would happen if we set off all of the nuclear warheads at once?
Oh.
It was like on the extreme, not exactly this extreme, but like mammals might go extinct.
Oh, because being warm-blooded, or
no, just it would be just crazy. No one would see the sky for many, many years.
Yeah.
The radiation. I mean, Kevin can speak more to it than I can, but like,
I think we'd be fine.
So you're a big nuclear proponent, Kevin. You think that there is a lot of hocus pocus around.
I think people went through a lot of effort to try and scare people a lot for good, not for bad reasons. I think they tried to do it for good reason, because I really do think it would be horrible. But in terms of, like, Carl Sagan used to really push the nuclear winter theory, and I haven't seen super strong evidence for that. But I mean, I don't want people to not be scared of it, but I think the fact that every major city on Earth would disappear should really be to me, that's definitely its own deterrent. I don't know why we need extra. I don't know who's hiding outside. I mean, I guess it's people are like, I'm not moving to the city. Like maybe they're like, oh, fine, blow them up. I think it'd still be really bad if every major population center on Earth like was destroyed, or even half of them. I don't think we'd be like, great. I mean, I just remember how annoying it was when toilet paper stopped being sold in stores at the beginning of the pandemic. Imagine that times a million.
Yeah. Talk about the death of millions of people. You're like, think about the supply chain. Oh, no.
The supply chain would be a nightmare, dude.
Kevin, I guess also what I was referring to is you think that there's a huge stigma against nuclear energy, which you think is clean, and even when there are whoopsie daisies, they're not as bad as the fracking contamination currently going on. All the other stuff, oil. These two are
totally related, because a lot of activists and politicians, they tried to conflate the two. Like, oh, it's so bad to have a nuclear war, which it is. But then they were like, oh, we'll all go extinct from all the fallout. That's just really not true. Like, there's even from a nuclear warhead, which is the biggest release of fallout you can have. Lots of people stood right next to these tests for decades. This doesn't just kill everybody. It did a lot of damage to Hiroshima and Nagasaki, but that's because people were directly under them. They don't ruin land forever. You can go to the Trinity site and you can go there, and yes, it's radioactive, but you don't get cancer from visiting it. And definitely it's true from even a nuclear accident. Like, very, very few people get sick, if any, from nuclear radiation, even when there's a fallout zone. There is no solid evidence that nowhere near thousands of people got cancer from Chernobyl, and Chernobyl was absolutely the worst nuclear power plant disaster there was.
Yeah.
And no one got hurt at all from Fukushima.
Yeah.
So
I heard the stats on the dumping is the water is what they're dumping out.
Yeah, they're dumping out water now. Yeah.
The concentration in that area of the water would have a lower radiation contamination rate than a banana at the grocery store. It's like the dilution would be enormous.
Tritium is a really good example. Tritium is radioactive, but just, again, this is complicated because if you don't know the details of nuclear physics, but it's a beta emitter of 18 kilovolts. It can't get through a single layer of cells, basically. Like, it's one of the most harmless forms of radiation there is. And it is natural. It's in the water all the time anyway. So it's just like, it's not even a thing, but that doesn't matter. It's very hard to convince people.
We should just tell Gwyneth Paltrow that this stuff is good for you. And then all these people would be like, we should have more of it. I want to get good beta rays. Over here it's good with vaginal rejuvenation. What can you just remind me? Alpha, beta, and gamma are what?
They were named in order of discovery. So alpha, beta, and gamma were discovered in those orders. So alpha is a helium nucleus. Then comes beta, which is an electron moving at relativistic speeds, sometimes almost the speed of light, usually about half the speed of light. And then gamma is an actual photon, but with a really high energy, roughly the same energy as a beta, usually between 0 and 8 MeV, although mostly around 1 MeV. So 1 mega electron volts. So that means it has 1 million times more energy than like a photon of UV light, or 2 million times, 3 million times more energy than a photon of green light. So when a green light hits you and you hits your eye and you see green, that's 1/1,000,000th the amount of energy that's in a gamma. So that's why when a gamma comes, it can do damage. It can scatter things off, and
that's really green. That sounds very, very green.
Yeah.
What kind of rays come out of a thermonuclear explosion?
Pretty much all of them. Pretty much all of them. Alpha, beta, gamma, proton, and neutron radiation all come out. Now, neutron radiation is a really important part of it because that doesn't travel very far away from the bomb, but internally, that's what's making the reaction happen. You make multiple grams of neutrons in a microsecond inside of a nuclear explosion. So that, like, when I say you make grams of, I mean, like, because you free these neutrons, there's just suddenly like free neutrons everywhere. That entire sphere is full of neutrons, and they're participating in the chain reaction. So and they grow exponentially. You know, from the moment of detonation, they just grow and grow and grow and grow and grow until the explosion has expanded so far that then they finally start to go back down, and that pretty much determines the yield.
So I'm asking so much about the science. I'm trying to remind myself this is about the movie.
Yeah, I think you guys are just trying to get me on the watch list or something.
State secrets with Sam Stanford. That's
come on my next review panel. Like, just I'm gonna be like Oppenheimer, sitting there imagining myself with no clothes on, going like, so did you seriously just do a podcast about this, Kevin? You thought that was okay?
Any inaccuracies in the movie that you saw? Things that were like,
yeah, the
Not
Apple
really.
event.
Yes,
with
the
Black
family, the family of Oppenheimer did not appreciate that. Actually, they made a comment about that. They said there's no evidence that he tried to kill his TA, and he did get in trouble for poisoning an apple. But the fact that it was actually cyanide, there's no evidence of that. That was sort of pulled together. Niels Bohr was not the one who stopped it. I don't know actually what stopped it.
Yeah,
there's a Veritasium episode where he talks about the same incident. You can there's a little bit more information about that. Although even there, I'd say Derek didn't quite. Good guy, by the way. I don't think he quite gave Oppenheimer the freedom to the benefit of the doubt that the family did. And I gotta say, I really think they would have kicked him out if they had thought he had actually tried to kill someone. I really do think they would have kicked him out of Cambridge. I don't think they would have said, okay, I know he's a rich guy. I know he's a rich guy and maybe had some buildings in the works or something, but I don't think that killing your TA is something that most schools are, I know they weren't woke yet and stuff, but still, they just, even back then, that was like, there's certain limits.
Conduct, poor.
Right.
Maybe it was X-Lax, that's
my guess is that it was probably something like a laxative.
Probably.
It was more a prank than anything. And, it's pretty sad. Pranks get out of control, but being accused of
that happened in my middle school, by the way. A kid dropped X-Lax in a teacher's coffee.
Whoa!
But it didn't melt, and she was just like, "What the fuck is this?" And the kids ratted out the kid who did it, and the teacher sued the parents because he tried to. So
that's insane. So
yeah.
do we know why?
I got to tell you this about that scene.
Shitty middle school, man. It was just awful kids. Just terrible discipline problem at that school.
I got to tell you something that really spoke to me in that scene.
You think the teacher deserved it? What?
No.
Like, what does the teacher do to get poisoned?
No. I meant why towards like. I'm sorry. Back to the movie in terms of like. Do you know why he tried to poison or do whatever to Blackett's apple? Is it just because he wasn't?
That because the guy was a jerk. He's a dick, man. Like that part, I totally sympathized with.
Yeah,
he was just like, no, his guy was like, he tried to get him to. They showed it to try to. I don't know if that's actually what happened, but he would do stuff like that. He was a bad experimentalist. He was clumsy. They showed that really well. That's totally true. He was not good at experiment. My experience was very much the opposite, where I wanted to do theory, and I was told by my experimental teacher, he's like, don't go study string theory. Like, I know it looks cool right now, trust me. And he said, be an experimentalist. And he said that to me because I'm good at experiment. So I had the opposite experience like that. And as a result, I didn't try and kill my TA. So, but that scene though did speak to me. I don't mean the part about poisoning your teachers. The part that really spoke to me that was so funny is that he's this shy little grad student guy, and he's so excited to go see Niels Bohr and everything. And he goes in. And the reason that scene was so cool is because a nearly identical scene happened to me, except it wasn't Niels Bohr. When I was in grad school, I snuck onto the set of Thor, which I was a science consultant for, and I snuck up and I nervously approached to meet Kenneth Branagh, who was the director of Thor, who was playing Niels Bohr. And so I had this scene that was like nearly identical. Like, this is like when I was in grad school and I tried to go meet Kenneth Branagh, except he wasn't pretending to be someone else. Well, he's pretending to be a director, but I mean, he was basically himself. So that was really cool, man. I love seeing that.
That's wild.
And I didn't even try and kill anyone.
That's amazing. My goodness. I think that was really the only thing that stood out to me in terms of like what was off in the movie. I don't think there was really anything. I think it was documented extremely well. But that's without me reading Prometheus. I don't know if you guys read Prometheus, the book that was, kind of Oppenheimer's story.
No, were we supposed to read that before the?
Oh,
Is that our homework?
Kevin,
I just said I did it.
Kevin, we told you this 2 days ago. You had ample time.
I think another actor. He had his clothes on the whole time he was being in front of the committee. Oh, that was artistic license. Okay, all right. I didn't...
How did you feel about Feynman in this movie? Played by,
I thought it was great. I loved it. Yeah. They showed some other cool thing, like they showed him playing bongos, and that
I
story,
love that.
Yeah, and that story about him not wearing glasses is true. Yeah. He did the calculation. He was like, no, it's pretty much the damage comes from UV, and I'm fine. And so he sat behind just regular glass, and he got to see it. So he's one of two people who got to see it the first time with their bare eyes. The other guy was an accident. The other guy dropped his glasses. So
wow. Do we know he did that? I don't know.
Maybe.
Would you say, you've said in the past that Feynman is like your number one quantum physicist?
I think he's the best physicist. That's my personal take. But,
yeah, okay.
But I don't like to make lists.
That's fair. The thing that struck me about, because I read Surely You're Joking at your advice, and Feynman is a guy who it's easy to miss how good of a scientist he was, because he's also such an interesting, funny guy. Mm-hmm. Who happens to be the greatest physicist of all time. And what I noticed in this movie was a lot of these guys were like pretty cool. They had a lot of sex with women who weren't their wives, or maybe they were each other's wives. Like they were sociable. They were like, the life of the party. They were into political movements. These people weren't just one kind of smart. They seemed to be just rather brilliant people in a lot of different categories.
Yeah.
They were communists, maybe. Yep. We don't know. Yeah, it was. They were polymaths. I thought that was cool.
Mm-hmm.
Definitely. So I have a question for you guys, just as like a final send off. What is your overall take on this statement where Oppenheimer, I guess, famously stated that like I have become death, the destroyer of worlds. What is your final take with Oppenheimer and how he handled it, and to the comments of people that say what he did was extremely evil, or what other people were saying it was extremely heroic? What are your comments, Matt? What do you got?
This is one place where I feel like a bit of like a religious fervor, and that sometimes we need to pursue science, we need to pursue curiosity. Sometimes there's a negative fallout from that, and sometimes really bad. And this was an example where it was used for very, very evil things. But overall, curiosity and the bold pursuit of science leads to the betterment of humanity. And we should not be afraid to move forward, knowing there will be steps backward and there will be wicked characters. Overall, the more we know, the more we explore, the better we will be as a human race. And then a bomb goes off right now and it's just our skeleton. I don't know. You know what I mean?
And I have a fairly religious take on it also. I think it's really important that I see a little bit of a metaphor before the first time that we explored getting knowledge. It was also something roughly the size of an apple. Knowledge can be viewed as a weapon or an evil thing, and it always can be, but it can also be a thing that creates love and creates procreation. I think that was also demonstrated in the movie very well. But I think it's important to remember humans did not invent fission. They did not invent the nucleus. They did not invent nuclear power. These are things that exist. God invented those things. Those things exist. And humans just discovered it. And the race in the movie was to discover it first. It was not to invent something that wasn't there already. And we're in a similar position now where we know that it's there and you can't unknow something. And you can use it to be good or you can use it to be bad. And we're given lots and lots of opportunities to use it to be good.
I agree with that. Don't smelt the iron ore because you can potentially use it to make a sword. That's the gist of it. Countless examples. Well, guys, thank you so much for being on the podcast. This has been absolutely fantastic. Hopefully we brought, some really interesting and I guess awesome perspectives to the Oppenheimer movie. And, I'm glad that I was able to talk to you guys about it. So thanks for being on the podcast.
Thanks for having me. Thanks for your time.
Yeah. Thanks for having me.
All right. Cheers. That is all for this episode of Everything STEAM. I just wanted to take a quick second and thank Kevin and Matt for sharing their movie opinions, expertise, and experiences with regards to Oppenheimer, physics, history, and much more. If you want to connect and see more of their content, feel free to head to my website, everythingsteam.org, and go to this episode's page for their links. I would also love to mention my amazing team for their collective efforts to make the show happen. This podcast was edited by Ariel Piermont. Clips that you'll see on social media were created by our new intern, Molly Chakery, and our episode art was created by Gabrielle Edmiston. After the episode, please give our podcast a rating and review on whatever platform you get your podcasts on. We're always looking for feedback, and the rating would greatly help us out in the fight against those algorithms. Lastly, be sure to check us out on the socials for podcast news, upcoming episodes, and just fun STEAM content. You can search Everything STEAM on Instagram, TikTok, Threads, and Facebook to join in on the fun. Once again, thank you for listening to Everything STEAM. I'm your host, Sam Stanford, and as always, stay curious.